Welcome to another lecture for Composing with Sound. This lecture is focusing on signal processing effects. The topics for the lecture include long and short delay effects, performance systems with acoustic instruments, and a quick look at Max for Live. Our goal is to understand long, medium, and short delay effects and consider delay as a resource for your creative projects. Delay effects are built around a circular memory buffer into which audio samples are written at a regular rate and from which they can be read out. There are three classes of delay effects: short delays, which include phasing and flanging effects, medium delays that include chorus and doubling effects, and long delays that include echo and multitap delay effects. I'll start the lecture with a quick example of creative use of a simple delay. This is a piece called Out of Silence for piano with delay by the Australian composer Robert Davidson. This performance is performed by the pianist Tamara Anna Cieslawska. The score asks for a delay set at 4 seconds with feedback of minus 8.5 decibels. And this produces about 3 repetitions after 4 seconds. You can see an excerpt of the score here, and I'll just play you the opening section from this piece. You can hear how a contrapuntal structure is built up with this set of delays that come in after a certain point in time, a sort of canon form, automatic canon form. And I think this is a really nice example of how a simple delay effect can be used very effectively in a creative context. At the heart of any delay effect is a fixed length buffer in computer memory that is continuously being filled with a stream of samples. Once the buffer is filled, it loops around to start again and overwrites the previous samples. So in the diagram on the left-hand side of this slide, you can see the circular buffer represented as a series of cells, and inside each cell is a single sample, a single measurement of the amplitude of the signal, and these cells are filled at the sampling rate, 44,100 samples per second. You can see that there is a write position, so this is where the current signal is being written into the current cell in the circular buffer, and there is a read position, which is reading out from the buffer. Now we can have as many read positions as we want separate echoes from the signal. And the red arrow shows the delay time, the amount of time that's elapsed between when the signal is written into the buffer, when it's recorded, and when it's played out of the buffer from the read position. And so the write and read positions move around the buffer in a circular motion. On the right of the slide, you can see the use of the tap in and tap out objects in a simple max patch. So the tap-in object represents the circular buffer, and the audio signal going into it is the right position, or the right pointer. The argument to the tap-in object sets the maximum length of the circular buffer, in this case 10,000 milliseconds. So after 10,000 milliseconds, 10 seconds of audio have been written into the buffer just overwrites whatever was there previously as it wraps around in the circular buffer. Each tap-out object represents a read position, or read pointer, and the arguments in the tap-out objects specify the delay time between the write position and the read position. So here we have a read pointer at 100 milliseconds and another read pointer at 125 milliseconds. So, as I mentioned before, delay effects can be divided into three classes of effects. Long effects, which include simple echo effects, multi-tap delays. The Davidson piece that we heard is a simple echo effect with a limited amount of feedback. Medium delays include chorus effects, double tracking, stereoizing effects, and similar sorts of effects. And short delays include phasing and flanging. So we want to learn a little bit about these effects. So to get us thinking, I'm going to borrow some video material from LinkedIn Learning once again. This is a video from an excellent series called Audio Foundations, Delay and Modulation by Alex Case. And I recommend that you come back to LinkedIn Learning and check out the complete series of Audio Foundations videos if you haven't already done so. Okay, just to recap. Long delays, or echo effects, occur when the delay time is greater than 50 milliseconds. Echo is perceptible when the delay time exceeds a threshold of about 30 milliseconds. Echo occurs in natural environments due to the fixed speed of sound in air, which is about 343 meters per second, or roughly 3 milliseconds for every meter that the sound travels. And we get echoes when we have reflections from large solid surfaces. A series of echoes occurs when large solid surfaces are parallel to each other and at a distance greater than 10 meters. So 10 meters times 3 milliseconds per meter gives us that threshold delay time of about 30 milliseconds. So when the delays are longer than that, we get a clear set of delays. We can very simply make an echo effect in Max using the tap-in and tap-out objects. And we can create a series of echoes by feeding the output of the tap-out object back into the input of the tap-in object, or mixing it in with the direct signal. As long as the gain of this feedback path is less than 0 dB, or less than the maximum amplitude of the signal is fed back into the tap-in object, the echoes will slowly die away. And I'll just quickly demonstrate how this patch sounds and what a long delay sounds like. Okay, in this patch, I'm using the SF Play object to play back a vocal track by the artist Lindsay Ollard, a track called Catching Up. And you can see that the direct signal is fed through to the DAC object, and it's also fed into a tap-in object. And I've used a gate object to switch so that we can turn the delayed signal on and off. You can see that a tap-out object sets the initial delay time at 600 milliseconds, so a little bit more than half a second. So here's the direct track.
I'm just catching up with yesterday. By tomorrow, I'll be ready for today.
And if we turn on the delayed signal, you should hear that we get two sets, the original direct and the delayed signal 600 milliseconds later.
I'm just catching up with yesterday.
So that's a fairly straightforward kind of effect. Now, as we add feedback, we use this gain object to control the amplitude of the signal that's going back into the tap-in object. We should get a series of delays dying away.
I'm just catching up with yesterday.
And you can hear those delays falling away there. Now, as we reduce the amount of feedback, we should reduce the number of discrete echoes that we can hear.
I'm just catching up.
So I'll increase it a little bit and we'll hear a few more.
I'm just catching up.
And a little bit more.
I'm just catching up.
And then if we set the gain to 0 dB, so 128 on these gain objects passes through the entire original signal, this is what happens.
I'm just catching
As you can hear, the signal continuously feeds back into the input, comes out of the output, goes back into the input. Now, if we were to set the gain just a little bit more than unity, than 0 dB, we should hear that echo build up in level each time because we're boosting each delay.
I'm just catching
So you can start to hear the distortion occurring there as the feedback path builds the level of the signal each time. So that's a simple echo effect. We can create more interesting delay effects using what's called a multi-tap delay. So we just add more tap outs to create more separate delays. And this, when they're set up in a stereo field, they can create some really interesting motion effects, the classic kind of ping-pong stereo effect where the echoes bounce from the left to the right channel. Here's a quick demonstration of that. Okay, in this patch we have the same audio track and we have 3 separate tap outs, one at 50 milliseconds, which is right on the threshold of what might be considered a delay, and you might hear a kind of metallic effect when the delays get short like this. One tap at 100 milliseconds and one at 200 milliseconds, and the patch has been augmented with these little pan sub-patches. So the short delay, first delay is panned to the left, the 100 millisecond is panned center, and the 200 millisecond is panned to the right. Now, normally we would be able to control the level of the delay effect compared to the direct sound, but in this example, they're both playing at the same level. And this is what it sounds like.
I'm just catching up with yesterday. By tomorrow, I'll be ready for today.
So you can hear it creates a sense of width. It's fairly overdone in this example because, as I mentioned, we've got no level control, but we could simply add that. And we can fatten up the effect by adding some feedback. So instead of a single echo in the left, center, and right, we get a series of decaying echoes.
I'm just catching up with yesterday. By tomorrow, I'll be ready for today.
Okay, so you can hear that those individual delays fill out the space. So that's the basis of a simple multi-tap delay. A whole family of interesting effects are created with modulated delays. By modulating the delay time, we create something like the Doppler effect. As a moving sound source travels towards the listener, because sound travels at a fixed velocity in air, the wave fronts bunch up, causing a perceived increase in frequency. As the source moves away, the frequency lowers. Now, you will have heard this Doppler effect anytime you've heard a car horn or an emergency vehicle siren. As the vehicle moves towards you, the pitch rises, and as the vehicle drives away from you, the pitch drops. Now, to simulate this effect, we can move the reed pointer forwards or backwards in the circular buffer. And now what happens when we do that is when we're moving forward, we skip over a number of samples, effectively speeding up the playback rate. Or as we move the pointer backwards, we play some of the same samples twice or more, reducing the playback rate and therefore reducing the pitch. So in this max patch, we can provide some examples of modulated delay effects. Now, the Doppler effect, for example, is perhaps something that you might want to use in a sound design situation. So here's our, let me set this up. Here's our direct sound.
I'm just catching up with yesterday.
And here's our Doppler effect. So we've got a modulation rate of 5 Hertz. Quite a large depth and of plus or minus 52 milliseconds and a depth of 100 millisecond. And this is what the direct plus the delayed sound sounds like.
I'm just catching up with yesterday.
Perhaps more effectively demonstrated if I get rid of the direct sound. Get rid of the direct sound. And here it comes.
I'm just catching up with yesterday.
So you can hear that rising and lowering of the pitch, and we can create something a little bit like vibrato. So modulation rate of 4 Hertz and a depth of plus or minus 2 milliseconds.
I'm just catching up with yesterday.
Perhaps a little bit slow for vibrato. Let's speed it up a little bit.
I'm just catching up with yesterday.
And perhaps too much depth.
I'm just catching up with yesterday.
So rather exaggerated vibrato effect. There are some classic effects of this type using medium length delays. So 2 that you might know of are chorusing and doubling. To create a chorusing effect, we set the delay time about 25 milliseconds, so we call these medium delays, and we modulate it at a depth of about plus or minus 3 milliseconds, so moving backwards or forwards, plus or minus 3 milliseconds from the set delay time. And we create that motion at a rate of less than 1 Hertz. That gives the effect of a second voice with slight timing and pitch variations, as if it was a duet, as if there were 2 voices singing. And we can build on this effect by adding feedback and by creating a stereo version. So a stereo chorus has some feedback and has different delay times feeding the left and right channels. So here's an example of that in Max. So here's my stereo chorus patch. So you can see we've got single tap in with 2 reed pointers. Initially, the reed pointers are set at 100 milliseconds, but I have some controls up here which modify the read time. So I've got a cycle object which moves the reed pointer backwards and forwards. And I set the rate here with this number, so I'm setting it to 1 Hertz. I'm multiplying that signal by some offset amount, in this case 3. So we're going plus or minus 3 milliseconds. Remember that the output of the cycle object produces a signal that goes plus and minus 1. So multiplying that by 3 gives us plus and minus 3, which gives us an overall change of about 6 milliseconds. And then we're adding on some fixed amount of delay time, in this case 25 milliseconds. So we're moving the delay pointer back by 25 milliseconds and then shuffling it backwards and forwards at a rate of 1 hertz over a range of 6 milliseconds. We call it the depth. And so you can see I've got another set of controls which are controlling the read time of the tap out object, slightly different modulation rate, same depth, and a slightly different delay time. Once again, I'm bypassing the signal here with some gate objects. Here's the direct sound.
I'm just catching up with yesterday.
And now we're going to add our stereo chorus effect.
I'm just catching up with yesterday.
And as you can hear, it makes a much fatter sound. Now, I hope you're listening with headphones, otherwise you won't hear the stereo effect at all. Okay, just to recap some of those ideas, here's Alex Case on medium delays. Some more powerful effects can be created when we add extra voices with feedback. So once again, here's our max patch. We can add some feedback to create an even bigger effect. Now, once again, this is probably a little bit over the top because we've got no volume control over the added chorus.
I'm just catching up with yesterday. By tomorrow, I'll be ready for today.
So you can hear the big, fat vocal sound, a big cushion of sound. Perhaps that chorus, perhaps that feedback takes away from the chorus and doubling effect. Okay, now Alex Case is going to introduce us to concepts around short delays and the effects of phasing and flanging. So as you've heard, short delays can be used to create a range of interesting effects, including phasing and flanging. So that sound that sometimes referred to as phasing is caused by the comb filtering effect that Alex Case talked about. And we can get phasing effects when we have reflections, say, from a glass window in the studio, or a reflection from a music stand in the studio, or when we have two microphones placed at short distances, different distances to a single source. We get that kind of hollowed out, sucked out effect. And where that distance changes, so when you've got a performer moving backwards and forwards from a fixed reflective surface, that phasing effect can sweep up and down the frequency band, and we can simulate that effect using short delays. The flanging is a delay effect first produced using a tape recorder. So the word flange comes from the flange of the reel of the open reel tape recorder, and you could slow the tape down just by pressing your thumb on the reel of the tape machine, which would slow the pitch down, create a delay with another version of the signal that was playing at normal speed. Flanging uses a delay around 10 milliseconds, and phasing uses shorter delays around 1 millisecond, and phasing produces that swept comb filter effect with deep notches in the frequency response, whereas flanging produces more like a chorusing effect, I suppose. So here's some examples of that in my max patch. Okay, so with our modulated delay patch, we can create a series of different types of effects. Here's our direct sound once again.
I'm just catching up with yesterday.
And our flanging effect uses a delay time of around 10 milliseconds, modulating at less than 1 hertz with a depth of plus or minus 1 millisecond. And this is what it sounds like.
but I'm just catching up with yesterday.
And you can hear that characteristic metallic sound that's produced by delays of around 10 milliseconds. Let's listen to a really short delay. So this is a phaser effect. So our delay is set to 2.5 milliseconds, and we're going plus or minus 1 second. So we're getting down to a delay of 0.5 milliseconds and up to a maximum of 3.5 milliseconds. Once again, modulating at a fairly slow rate, 5 Hz, and this is what that sounds like.
I'm just catching up with yesterday. By tomorrow, I'll be ready for today.
And you can hear that characteristic sort of sucked out sound down a pipe kind of effect that we call phasing. And that's how it's produced, very short delays modulated. Okay, so I'm just going to finish off with showing how we can integrate our effects design into Max for Live. So many of you may know that Ableton Live comes with the ability to make Max patches into plugins in Ableton. And it all starts with a template patch in Ableton Live. So here we are in Live, and down here in the Max for Live section, you'll see there is something called a Max Audio Effect, and we insert that into a channel just by dragging it in. And it has two new objects that we haven't seen before, plug in and plug out. Now this simple arrangement passes the signal from the input to the output. So here's my...
I'm just catching up with yesterday.
My signal being passed through the effect. There's an edit button which opens up a version of Max called Max for Live. And eventually that's going to open up. And here is the Max patch that we can start to edit. The components that go above the line here are visible in Max. And we're going to just get rid of the template items. There we go. You can see there's a little warning message there. We can get rid of that. And I'm going to get back into Max, and I've built myself a little patch version of the 2-channel delay effect. And so I'm just going to grab all of those bits. You can see there's plug in and plug out objects. I'm going to copy them and jump back over to Max for Live. And whatever is above this line here is visible. So I'll just grab these controls for my left channel, pop those up there, grab these controls for my right channel, and pop those up there, and then place it in presentation mode, adjust the width, that's about right. I'll just save my patch and close the edit window. Jump back into Live, and there's our effect ready to go. We've got dry and wet sounds, and let's make some crazy effect here and have a listen to that.
I'm just catching up with yesterday. By tomorrow, I'll be ready for today.
Perfect. So instant Max for Live there, and of course any crazy stuff that you create or useful things that you create, you can then use in your Ableton projects. Well, that's enough for one lecture. Once again, some useful resources. These two classic texts. Rhodes Computer Music Tutorial has a lot more information on audio effects, as does Dodge and Jerse, and I recommend the LinkedIn Learning Audio Foundation video series. That concludes the lecture. More fun in the tutorial. Look forward to talking to you then. Bye.